Hi, this is Mrs. Bustamante. Today I want to have us look at the Phet, Colorado gases introduction lab a little bit, just to give us an idea of what we've been talking about with kinetic theory and to show us some of these particles in motion. So first I'm going to add some particles into my chamber here. It doesn't really matter how many, just some that we can see. And we notice it's at a temperature of 300 Kelvin. And just to give you an idea, remember Kelvin is Celsius plus 273. So 0 degrees Celsius, which would be where water would freeze, right, is 273. And we can see that the particles are moving, right? We see that they're bouncing off of each other. We see that they're moving in a straight line. And we see that when they collide, they transfer energy or continue to have energy. All these things we talk about when we talk about kinetic molecular theory. We can see that if let's cool it off a little bit. Let's go to about 273. Right? And as we cool it off, we talk about particles having energy, and that energy is part of heat. So notice I'm drastically dropping the temperature here, and the particles are moving much, much slower, which is what you would expect. They have less energy. They're going to have less collisions as we drop it way down. And if we went all the way down to 0 Kelvin, that would be where we would suspect all molecular motion to stop. We don't really want to go quite that cool today, so we'll heat it up a little bit. And we can watch as we heat it up here that the particles, here we go, you start to see that they're moving much faster than they once were when we were at a really cold temperature, which is also as we would expect. The other thing we can do is we can change the pressure, right? And notice if we take this, we can look at the pressure out here. Here's our pressure. Right now with our particles in here at 357 Kelvin, it says we have about a pressure of 6.5 atmospheres. But if I take those gases, and remember gases are compressible, and I really move it in, notice that same temperature, same amount of particles have a lot more pressure, meaning they're going to have way more collisions as I start to condense them into a smaller space, which is what you would expect too, right? Because they're going to collide more, they're going to hit the walls more, and they're going to hit each other. So we've kind of investigated the two ways we think about changing a state of matter even, right? We can change it by increasing or decreasing the pressure, and as these particles start to collide more, they can change the state that they're in, or as we change the temperature, right, as we provide more energy, maybe that means that they're moving faster and they're changing from, say, a liquid to a gas, right? Examples of how we can show phase changes and how we can see them in just general kinetic theory.